Let's look at a few examples here of all these different types of similarities. AA similarity, angle-angle similarity. Remember that means that two angles of two different triangles have to be congruent. And if they are, then we can prove that those triangles are similar. So I've got two triangles here. They're marked. This says that this angle A is congruent with this angle D. It says that this angle B is congruent with this angle E. Therefore, because angle A is congruent with angle D and angle B is congruent with angle E, I got two different angles on this triangle, or congruent to two different angles on this triangle. Then those two, through AA similarity, those two triangles, triangle ABC, is similar to triangle DEF. If we were to subtract this from 180, then subtract this from 180, we would find that angle C would be congruent with angle F. Okay? If those three are congruent, then we know that those two triangles are the same shape, and their sides must be proportional. Now let's look at this one. This is different. We have a triangle ABC, and then we have triangle DEF. Okay? They both share angle C, so we can immediately say that they both have angle C in common with each other. Okay? So we know that angle C is congruent to angle C. However, we don't even need to use that one because we have two parallel lines. These sides here are parallel to each other and are cut by transversal, so that means that angle A must be congruent with angle D. And angle B must be congruent with angle E. Okay? If we have two angles, two different triangles, are congruent with each other, then those triangles, through AA similarity, angle-angle similarity, are congruent. So therefore, triangle ABC is similar to triangle DEC. Okay? Excuse me. All right, now let's look at side-side-side similarity. Side-side-side similarity says that corresponding sides have to be proportional. If they are, then the triangles are similar. So what we're going to do is we're going to take the small side of this triangle, which is 15, and set up a ratio with the small side of this triangle. So that's 15 divided by 24. If we take out 3 out of that, we get a 5. 3 out of that, we get an 8. So that's a proportion of 5/8. Those two sides are proportional to 5/8. Now let's take the middle side. That's the 20. Set up a ratio with 32. 20 divided by 32, we come up with this, with the same 5/8. Now let's take the longest side of each one. 25 divided by 40, 25 divided by 40, and again, those two sides are proportional with a 5/8 proportion. So if all three sides have the same proportion, then we know by side-side similarity, that means all three corresponding sides. We took small to small, middle to middle, long to long. Since they're corresponding and they are all proportional, the same proportion, then they are similar. These two triangles are similar. Okay? All right, we'll do some more in a little bit. Now let's look at SAS similarity with a couple of examples. SAS says if we have two sides of one triangle that are proportional to the corresponding sides of the other triangle, and the included angle is congruent, then we have SAS similarity. Well, we have two sides of this triangle, two sides of this triangle, and the included angles are indeed congruent. So all we have to do is check to see if the corresponding sides of those triangles are proportional. So let's go. We're going to take the larger of this one, and set up a ratio with the largest one of this. That would be 24 divided by 36. Well, if we divide both of those by 12, we get 2/3. Okay? So let's take the smaller sides of each one. Starting with this one over here, so that's 18 divided by 20. 18 divided by 20. We take 2 out of each one, we come up with 9/10. Can't reduce this any further. Can't reduce this any further. Are these two equal? Excuse me, are those two proportions equal? No, they're not. And because they're not, then these two triangles are not similar according to SAS similarity. They are not similar. Why? Because these two are not proportional. Okay? Now let's look at another one, another example. We have two triangles. We're told that the included angle between these two sides is congruent to the included angle between these two sides. So let's set up our proportions between these. We're going to set up those proportions just a little bit different. We're going to come over here and say, wow, is the short side of this one proportional to the long side of the same one, as the short side of this one is proportional to the long side of that one. Let's see what we come up with. 24 is to 39, 24 is to 39 is 8 is to 13. Okay? Short side to long side, 16 is to 26, 16 is to 26. Take 2's out of here, we took 3's out of this one. 24 divided by 3 is 8. 39 divided by 3 is 13. 16 divided by 2 is 8. 26 divided by 2 is 13. So, what do we have? They are proportional to each other. Because they are proportional, the sides are proportional, the included angles are congruent, then these two triangles are indeed similar through SAS similarity. So here we have some examples of triangles that are similar and one triangle that is not similar, that does not meet the rules that we were looking for. Let's do some more.